Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today we are going to discuss about a Schottky diode and its applications. So this is not Schottky diode, photodiode. So today we will discuss about a photodiode. Let us see the overview of today's presentation. So start with introduction to the photodiode. So we will discuss the construction, basic construction of photodiode, and we will discuss what is the basic principle, working principle of an operation of photodiode, and we will discuss the different characteristics of VI characteristics of photodiode, and we will discuss different applications of photodiode, and we will discuss different disadvantages with the photodiode and conclude with the summary. So coming to the introduction part, photodiodes are a special PN junction diodes operated in reverse bias only. So these photodiodes are operated, specially designed to operate in reverse bias condition and designed for detecting optical signals, so light signals. So these photodiodes are able to detect light signals. Okay, so we can say this is the, you can observe here the symbol for the photodiode. So it's just like a normal PN junction, it look like a normal PN junction diodes except these arrows. So what do these arrows represents? These arrows represents light impinging on the diode. So there is another special construction is there. So on that particular area, when light impinges through the diode on the diode, photodiode, then that light will be converted into electrical energy. So photodiodes main feature, the photodiodes feature a transparent window which allows lights to fall on it. So we will see in the next slide that the basic construction of photodiode. So in that you come to know that how the construction will be, where the light has to be impinges on the photodiode. Photodiodes are also addressed with various names like light detector, photodetector, photosensor. So these are the different names for photodiode. So of course, actually photodetector, there is a difference between photodetector and photodiode. Actually photodiode are again classified into PN type diode, photodiode, PIN diode, and different types also there. 3 types are there. So mainly we focus overview of the photodiode only. So silicon, germanium and indium gallium arsenide are some of the photodiode materials. So to construct or to manufacture photodiodes, so we can use silicon, germanium, indium gallium arsenide or some of the photodiode materials. Okay. So this is about introduction to the photodiode. So let us see what is photodiode. So you can observe here. So this is the real-time image of photodiode. So in this area, this is the area on which the light will be, the light rays will be focused on particular area, this area. And when light focused on this, when light impinges on that particular, focused on that particular area, so they will be converted into electrical energy. So how it happens, the mechanism, let us see. So it converts light energy into electrical energy. Photodiode converts light energy into electrical energy, or made up of photosensitive semiconducting material to absorb the light when falls on it. So when this is the light semiconductor material to absorb the light when falls on it. And then photodiodes are operated under reverse bias condition below the breakdown voltage. So this is the basic feature of photodiode. So it works under reverse bias and that too below breakdown voltage, under breakdown voltage conditions. When the energy, so h nu is the energy, so light energy, photon of the photons that strike is greater than the energy gap. So we know that there is any material having energy, conduction band and valency band. Okay, So when the light energy which is focused on, or which is focused on that particular light absorbing material, semiconducting material, so it must have the photon voltage. So whatever the energy of the photon that strike is greater than energy gap of the semiconducting material in the photodiode, electron hole pairs are created near the depletion region. Okay, so again it is a PN type semiconducting material, and there is a special construction is there, arrangement is there, so to absorb the light rays. So when light rays strike that particular semiconducting material, so what happens, that the condition is the light energy h nu, the light energy having energy h nu of the photons must be greater than the energy gap. So it should be energy gap between the semiconducting materials. So obviously, so there is a energy band gap, we know, EC, EV. So this gap must be, so let us say this gap is of this is let us say V gap is EH, let us say. So this energy is EH, and now the photon energy, the light energy which is strikes this particular component must be greater than this EH. So that means H nu must be greater than EH. So in such case, what happened? Electron hole pairs are created near the depletion region. Electrons and holes are separated before they combine in the presence of electric field. Okay, so electrons and holes are separated before they combine in the presence of electric field. Okay, so after applying any electric field, the electrons and holes are separated. So when electric current passes through it, electrons are accumulated in the N side and holes are in the P side. EMF, electromotive force, is generated when electrons and holes move in the photodiode. So current flows through the device when an external load is connected. So current flows through the device when an external load is applied. The magnitude of the photocurrent generated is directly proportional to the intensity of the incident light. So obviously the magnitude of photocurrent, I, current generated, is directly proportional to the intensity of light energy. So whatever the intensity light energy having which falls on the, or which strike the photodiode surface, that has magnitude is proportional to the light intensity of the light. In reverse bias condition, as the intensity of light increases, the current also increases. So this is again the photodiode is specially designed to operate in reverse bias condition. So in reverse bias condition, as the light increases, intensity of light increases, the current also increases. So working of photodiode. So if you observe clearly, it can be observed clearly on observing this construction. So here, so we have a P-type material. So this is depletion, this is bulk N-type silicon material. So N-type silicon material is lightly doped and P-type material is heavily doped. So those forms PN junction, and this act as a silicon nitride passivation AR coating. So anti-reflecting coating, because the sunlight should not be, so whatever the light rays impinges on this surface, it should not be wasted, right? So most of the energy has to be captured by the semiconducting material. So otherwise, when it reflects, the sunlight reflects back, so there will be a loss of energy. So therefore, to avoid this, we have to use this passivation AR coating. An anode and SiO2 diffusion mask is also placed, and then we have another N-back contact diffusion backside. So in order to capture all together, so rays, so must be what we can say? We can say all the rays should be properly aligned. So back metallization cathode. So it acts like anode and cathode. So negative. So reverse current flows for no reverse voltage. Okay, if you are not use any voltage, we are not applying any voltage, so reverse current will flow. So reverse current flows for no reverse voltage. Even we are applying no reverse voltage, so there is some current. The junction of photodiode illuminated by the light source, the photons strike the junction surface. The junction of photodiode is illuminated by the light source. The photons strike the junction surface. So this is the junction. So when light strikes the surface of the photodiode, so what happens? Photons strike the junction surface. So this is the junction surface. The photons impart their energy in the form of light to the junction. So light energy has impart some energy to these particles. Electrons from the valency band get the energy to jump into the conduction band and contribute to the current. See here, so the light energy, the particles, what are the particles at the junction? So they acquire some energy from the light and they move from move freely within the circuits. So electrons from valency band get the energy to jump into the conduction band. So whatever the electrons present in the valence electron, they acquire some energy from the light source, and then they will contribute to the current. In this way, photodiode converts light energy into the electrical energy. Now you can observe here, this is a PN diode, this is a light source, and this is, we can represent this as a resistor. So the current flows in the photodiode before light rays are incident on it is called dark current. So before the light rays striking the surface of the photodiode, there is small current flowing through the diode. That current is called dark current. As leakage current flows in the conventional diode, similarly dark current flows in the photodiode. So what is dark current? The main source for the dark current is again magnetic charge carriers. The characteristics of the photodiode. So what are the characteristics of the photodiode? So coming to this, if you observe on x-axis, we will take a reverse bias in volts. On y-axis, so you can say on this forward bias, positive axis and negative axis, and here on y-axis you can take a reverse current in microamperes. Of course, there is minute current will flow. So the light energy will be converted into minute current. The characteristics are shown in the negative region because the photodiode can be operated in reverse bias mode only. And the reverse saturation current in the photodiode is denoted by I0. The reverse saturation current I0, so you can observe here, this is the expression for the current flowing through the photodiode, right? So the reverse saturation current is represented by I0 in the photodiode, and it varies linearly with the intensity of photons striking the diode surface. So this reverse saturation current varies linearly with the intensity of the photon striking the diode surface. The current under the large reverse bias is the summation of reverse saturation current and short circuit current. Short circuit current also present because that is called, even we are not giving any input voltage, reverse voltage, so there is minute current due to magnetic charge carriers, the dark current. So combination of short circuit current and reverse saturation current into 1 minus e power v by eta Vt. So what is V? V is the applied voltage and eta is the material constant, that is 1 for germanium and 2 for silicon, and this is the actual current. So you can see this is the dark current. This indicates the dark current, first one. So even we are not giving any input voltage, there is a small current. So if you increase the reverse bias voltage, so the current, minute current, the current in of the order of microamperes will flow through the diode, and that is related to the intensity of the light. So that is directly proportional to the intensity. So this is 10,000 lumens per meter cube, meter square. So this will be the, for 10,000 lumens per meter square, what will be the current? 100 microamperes, minus 100 microamperes. Similarly, for 1500 lumens, so this is intensity of light, right? So for 1500 lumens per meter square, what will be the current flowing through the diode? Minus 200 microamperes. Similarly, for 20,000 lumens per meter square, the current increases to 300, minus 300 microamperes. And for 25,000 lumens per meter square, it will be above minus 300 microamperes. So these are the characteristics of diode. So the current increases, which is related to the, depending upon the intensity of the light strikes the photodiode surface. Right. Coming to the applications of photodiode, it is used for detection of both visible as well as invisible light rays. So this is very important application. It is, photodiodes are particularly used for detecting light rays. So a few invisible light rays are there, visible light rays are. So invisible light rays can also be detected by photodiode. Photodiodes are used for communication system for encoding and demodulation purpose. So photodiodes are used in communication system, particularly encoding and demodulation purpose. So this is encoding and decoding, it comes under communication system like modulation. So modulation, demodulation. So modulation means we have to, in order to make your message signal travel far distances, we require some carrier. So adding up this message with the carrier is the modulation. So at the this process done at the transmitter end. At the receiver end, it has to be again retrieved. So your original message, which is clubbed with the, which is mixed with the carrier signal, in order to travel far distances, we have to do the modulation process at the transmitter, and at the receiver again you have to retrieve your original message signal. So for that purpose we have to use demodulation process. So in demodulation process we can use photodiode to detect the message signal or to isolate the message signal. So in such cases we can use this kind of photodiodes, and it is also used for digital and logic circuits which require fast switching and high speed operation. So you can observe in computer system, so we have different logic circuits, digital logic circuits, where switching is very primary factor. So switching speed must be there, so to change from one state to another state, otherwise you cannot get the proper outputs, right? So it is also used for digital and logic circuits which require fast switching and high speed operation. These diodes also find application in character recognition techniques and IR remote control circuits. So IR remote control, so TV control, so invisible rays are there. So in such case, so in order to detect these IR signals, so we can use this photodiode. Photodiode can be able to detect this IR remote control signals, and also character recognition. So each symbol, each letter we can able to calculate invisible letters and then use these kind of photodiodes. So all these are the different applications. So there are many other applications. So due to time factor, we have discussed only few applications of photodiode. So let us conclude for today's session. So we have started with the introduction to the photodiode. So photodiode operated in reverse bias condition, right? So the current produced by this photodiode in the photodiode is proportional to the intensity of light strikes the photodiode surface. And we have discussed the working of photodiode, how it works, the basic principle of working principle of photodiode we have discussed, and followed by what are the different characteristics, the basic VI characteristics of the diode. So depending upon the light intensity which strikes the surface of the photodiode, the current changes accordingly. So reverse, even we are not applying any input reverse voltage, so there is minute current flowing through the photodiode. That current is called a dark current, and that dark current is due to, again, minority charge carriers, just similar to the reverse saturation current in case of normal PN junction diodes. And we have discussed different applications of the photodiode, particularly digital circuits, RF circuits, and in order to detect visible and invisible signals, and in modulation, in particularly in demodulation circuits, we can use photodetector in order to detect the signals. So that's all for today's session, and next topic will be solar cell.